accidents are not common. You don't face them every day. So, you will face a particular problem probably a few times in your life, 2 or 3 times in your life. An average CPB accident, around 200 or 250 documented bombs. Please come in, just problems. Now you need to practice. Now practice makes you perfect, and as far as accidents are concerned, nobody thinks that you have to prepare for an accident, but it's very important that you prepare for an accident, because all of these are low probability events, and one of the things that we have is that we have what is called as a reaction time. That is the time required to solve your problem. Now unfortunately that is very low for us. We have only a few minutes, seconds if not minutes to react. And as cardiac surgeons, you are not the only person here. You have an anesthesiologist, you have a perfusionist, you have what your staff nurse. So there are various teams, and all should work in synchrony. For you to have a ballet, come in. For you to have a ballet, you need to all dance properly. But if each one dances in his or her own way, it becomes chaos. So, and then standard protocols are required to allow coordinated response. So now, actually, for perfusionists, we conduct these as a part even of the exam, and in fact, technically, even the skills have to be developed by the surgeon so that he can work in tandem with the anesthetist, so that they can work in tandem, the staff nurse, so that they can work in tandem. Next slide. Do you have any control? Now you can see this is a very famous example of a plane which landed on the Hudson River. There have been only 3 documented water landings. You might have seen in all of in the aeroplane they give you the card and they show one figure of a plane which has landed on the water and water evacuation. It has happened only 3 times in history. It's not that it happens every day. Most of the time it has crashed onto land. But this is the only successful water landing documented. You will think that this is easy. It's an extremely difficult process, and you can see how both doors are open. If all the people had gone out on one side, the plane would have tipped. Now you have to follow a sequence to be able to land on water. You know how it was done? It was all done because it was practiced on a simulator multiple times. Now you can imagine it has happened only 3 times in history, which only once it has been actually successful. Now that is because the co-pilot was reading out to him what is to be done, and the pilot was doing it. Co-pilot reads, the same time. So it was a standard protocol, and because they followed every step, they were able to do this. Now you must remember to open both sides of the doors. Come in. You must know that you have to open both doors. If you don't open both doors at the same time, everyone will rush out to the same door and the plane will tip. It sounds stupid, isn't it? But unfortunately, those stupid things only are what counts. Okay, so you have to follow protocols even if it is an emergency. So you have to train yourself to do a thing in a particular sequence to be able to avoid a problem. For example, you know that you have to give heparin before going on bypass. People have died because of not having given heparin on bypass. Okay, but it sounds stupid, but it needs to be checked. That is why you always, the anesthetist has to draw out the syringe, confirm that there is blood, and then inject. Or else if you are injecting directly into the right atrium, you have to draw out and then inject, and after injection it has to be announced that heparin has been given. Why is that rule made? I'll give an example. When I was a student, in one of the OTs, the patient crashed. The anesthetist injected heparin without drawing. Actually, the patient was getting heparin releasing. She announced heparin injected. 2 things happened. She didn't draw. Now that thing she injected without injecting completely. Because the patient arrested at that time, you can come in. The patient arrested at that time and people can come in. So the patient arrested at that time, and the injection was not completely given, and the circuit actually clogged and the patient died. The patient went on bypass, but the circuit clogged. So that's a very important thing. So you have to follow every step, practice the step, and as a team also you should practice. That is what we are trying to tell. Now, okay, we will go now to the first problem. Now, the pump is, let us assume that the pump is not ready. Patient is arrested. How would you manage this? Pump is, yeah.
Hand muscle.
You start CPR. Okay, number one. Then pump is not ready. If you are not, your chest is not open. You give CPR and then you continue to open the chest. Why do you want to do internal massage? The cardiac output is more effective comparatively. But now, then next, what else would you like to do? Give heparin. So now you understand. You have to give heparin. If you do not give heparin, you will be in trouble. Remember now, there's another problem. Circulation is not good. So you must realize that the heparin may not distribute well. Immediately, patient arrest, pump is this thing. The additional thing is the perfusionist must, while he is preparing, he must call for additional help. Understood? You have to call for additional help. Surgeon has to call for additional help. The nurse has to call for additional help. Never forget this. You have to call for additional help. Otherwise, it becomes a massive mess. Chickens running around ineffectively. First step is call for help. Start CPR. Standard CPR is there. Go ahead with it. But the most important thing for us is that if the pump is not ready, the pump has to be put ready. Now, best thing is to anticipate. Which is, for example, if you have a severe aortic stenosis case, or if you have a left main, if you are planning to do, have the pump ready. There are various levels of keeping the pump ready. You know how you could get. Does anyone know how to get a pump ready fast? Well, okay, CO2. First you get a skilled perfusionist. Between a junior perfusionist and a senior perfusionist, let the senior perfusionist run his part of the show. Okay, so for example, Mr. Prasad here can do it very rapidly. He will get it ready in a couple of minutes. Whereas the junior perfusionist will take time. Number two. Then any other way now, that is level 1 preparedness. You keep the instrumentation required. You keep the heart-lung machine there. You keep a pump ready. You don't keep the pump ready. You keep the things ready. Next, what is the next?